course. Now, bionics is basically connecting robotic systems to your body. Now, this goes both ways, both controlling a robot with the electrical signals from your body and feedback to your body. For instance, we could design a pressure sensor on the tip of a robot finger, which drives a device on your fingertip, which actually puts pressure on your fingertip, so you can feel the pressure the robot finger feels. If you're controlling the robot hand with your own muscles, then you've got a complete feedback loop, and you could potentially be able to learn how to pick up a delicate egg with a robotic hand by feeling the biofeedback and controlling the bionic hand. Now, because we're not only building robotic systems, we'll be learning prototyping, manufacturing skills. Hey, we're even going to build a 3D printer. You could build anything from an exoskeleton to robotic prosthetics for someone who's lost an arm or leg, for instance. Now, as you'll see, measuring signals from the body is tricky. It's my hope that you'll be inspired to explore this area further. The sky really is the limit here. Do not discount the possibility that you could develop a novel way of controlling an exoskeleton, which enables a paralyzed person to walk again. It's actually easier to send signals to the body because you have this astonishingly well-designed supercomputer up here, which is amazing at figuring things out. So we can take advantage of the flexibility and adaptability of the human brain in surprising ways. Think outside of the box here. Neuroscientists have referred to this as the plasticity of the brain. It is this ability to learn how to process feedback. For instance, even with your eyes closed, you can see by touch different pathways, or you can see by sound. This is your brain finding other ways of seeing. This is the plasticity of your brain, its ability, flexibility, adaptability to be able to learn how to interpret various feedback. A company called YCAB developed a system which allows blind people to see using their tongue. The person wears a camera built into some glasses. They put a sort of lollipop on their tongue, and the lollipop actually displays what the camera sees as a grid pattern of electrical impulses on the tongue. The blind person is able to see using their tongue and can quickly learn how to navigate obstacle courses and even find and identify sports team logos. Deaf people are able to hear using visual systems, or, as you've seen I've tried to do throughout this course, feel sound through their skin. I'm hoping later on in this course to actually experiment with systems where deaf students can hear a wider range of sounds using alternative methods like the sense of touch. But this is all biofeedback, and I do hope to inspire all of you to think outside of the box in this area. So we'll start by reading signals from our muscles and using those signals to control a servo motor. One strong warning before we proceed. In order to read electrical signals in the body, we need to make electrical connections to the body. Use only battery-powered systems. You might be tempted to use a power supply, like these little things for charging USB devices. After all, it's only 5 volts coming out. That's safe, isn't it? I mean, what could possibly go wrong? I'll tell you what can go wrong. These things can fail. These wall warts can fail. The power supply on your computer can fail. Any of those can fail, and if it's powering your bionic circuitry and you made a really good electrical connection to yourself, you just hooked up your body to the wall socket. Now that's bad enough if you're hooked up to your muscles, but if you're trying to read brain waves, you've just hooked up high voltage to your skull. Needless to say, this is not good. Keep all of your electronics completely insulated and isolated from any high voltage sources and use only low voltage battery power. As it is, if you use 2 9-volt batteries for your dual power supply, that's 18 volts. When I was developing the prototype circuits for this course, one of the wires got pulled out on the breadboard, applying all 18 volts across the leads that were on hooked up to my arm. I definitely felt it. Now, it wasn't the end of the world or anything. I was just clawing at my skin trying to get the electrodes off, that's all. It was unpleasant, nothing more. However, that said, unless you're willing to get a shock, don't do this next experiment. I'll walk you through some procedures to try and avoid shocks, but as you can see, wires can get pulled from the breadboard while you're hooked up to your fully functioning circuit, and you get that wonderful feeling of electrons crawling across your skin. Also, you're going to be connecting wires to your body. Don't go wandering around the house wearing them, okay? You never know what can happen, as those bare wires could very well find a power source in the most unexpected way, and you can get a really nasty shock which can really hurt you. So only be hooked up to the circuit when you need to. Let's start by making the sensors. Now, you don't have to make these. Just bare wire taped to your skin with like first aid bandage will do the job. But I found these cheap and easy to make, and they were reliable. I made these using dollar store specials. I got an entire container of these from the dollar store for like, yeah, $2. They're just little sports ball stickers, complete with peel and stick backing on them. So I also got these brass snaps from the fabric store. Now make sure they're brass snaps. Solder will only stick to a few metals. Brass is one of them. Now these snaps have two parts to them and usually come in a card like this. There's your two parts. Take one off, and the top one with the socket, this one right here, you're going to solder a wire to it. You want a meter or a few feet long. You'll need 3 of these, and as much as humanly possible, try to keep the wires exactly the same length. You can see what I did here. I just used a length of my telephone wire and used 3 of the 4 wires and soldered snaps on them. We take the half of the snap with the dimple on it, and this will contact our skin to make an electrical connection. I put the snap in the middle of a peel and stick, in the middle of the peel and stick backing, and I trace the outline of the snap. I now take an X-Acto knife and cut through just the peel-off paper backing. Cut the circle out and remove it. I cut an X in the middle, right through the foam. Now push the dimple through the cuts in the foam, and the sticky back glue will hold the snap on there. Push the foam down over the dimple so that the snap can cleanly snap on and off. You've just made a sticky back electrode. When you're ready to use them, you just peel off the backing and stick it to your target area, but don't do that yet. Now, you can sometimes get 2 or more uses off the sticky pads before you have to replace the pad itself because the glue is no longer sticky enough. Just pull the snap off and then use it on a new pad. Optionally, to make better electrical contact to your skin, you can make a conductive gel. It's dead easy to make and dead easy and cheap to make. Just some good old aloe vera gel, which you can get at Walmart, the drugstore, and you want to mix it with good old-fashioned salt, just table salt. So aim for a ratio of about 6 aloe vera to 1 salt. So 3 teaspoons of aloe vera gel to about 1/2 teaspoon of salt. The ratio is approximate, you don't have to be exact. The table salt dissolves in there, mix it up good, and you've got conductive gel. You can then just use a Q-tip or a paintbrush, or just dip the tip of your finger in there. And put a very small dab on the electrode before you apply it to your skin. Doesn't take much at all, so obviously even a few teaspoons will last you a very, very long time. You can always make more just as you need it. This gel just aids in making a good electrical contact to your skin. You're actually trying to read electrical impulses underneath your skin, so we want to make the best contact possible. But I didn't use any gel at all on my prototype circuit, and it worked surprisingly well. Now, I'll show you how we'll use these sensors, but don't hook them up yet. The simplest, most obvious muscle to try and read is your bicep. So flex your pipes, follow that arch of your muscle, find the middle, and mark it with a washable marker. Or a pen. Now measure 3/4 of an inch or 2 centimeters lengthwise along the muscle on either side of that mark. You want 2 of your contacts on those 2 points, and the third contact is your ground, and so you need to ground somewhere where you don't have muscle electrical signals. So your elbow, or the inside of your elbow, for example, or even the side of your arm between your muscles. You don't want it picking up signals from your other muscles, because this is your reference point and it'll mess up the reading of your other muscles. Now, if you bruise easily and you're using these snaps, you may experience bruising if you stick the patches on first and then try to plug in the snaps, because you might have to press pretty hard on the snaps to get them to snap in which case just connect the snap first and then peel off the backing and stick it in place. I'd recommend starting with the bicep muscle first, as it's the easiest to work with. Later on, you can experiment with trying to hook up to other muscles. If you move your fingers, you can feel the tendon moving, and you can follow it to the muscle. You want to get as close to the center of the muscle as possible. The tendon doesn't produce a signal. Looking up anatomy charts, or even better yet, weightlifting and bodybuilding charts, can help you locate specific muscles you're trying to target. When you're finished, this is one of my favorite parts, just rip off the patches. Oh yeah, take it for the team. This is science, take it for science. It's only a few hairs that get ripped off in the process, no worse than waxing. All right, in the next lesson, we'll work on the rather frightening electronics.